Hi, here we are. We're still in our textbook, Unit 1, Lesson 5. So that's the classification in your textbook. And we're talking about how particles move when they're a solid, liquid, and gas in terms of energy, how much kinetic energy there is, and how the molecules are behaving or moving. Everything we do is tied to a standard, so this is the standard that we're working on. S stands for science, 8 stands for 8th grade, and I don't know what the P stands for. So in our game board, we are on lesson 3.1C, solid facts. And how do solids and liquids change states? So we'll go back to our heat curve and the discussion we had about what is a solid, what is a liquid, what is a gas, and what is plasma. So take a minute and refresh your mind about our last lesson and about what happens in each of those phases. And we're going to be looking at solids and liquids today. Remember that a solid has a definite volume and shape. The molecules are really close together. They're packed in together. So if you remember the example of the movie theater, that is when everybody was inside the movie theater sitting in their seats watching the movie. Really not moving around freely, still moving around, like vibrating a little bit, but you stay in your chair, you stay in the place. And you can see the animation on the screen where the molecules, the blue circles, are moving, but they're not moving away from each other. So we will be talking about the properties of water a lot this year. Water is one of the necessities for life and one of the things that allows life to be here on Earth. And so we'll be talking about the unique properties of water as we go along. So if you want to know what's happening in the water bottle up in the top right, you need to Google it and search for super cooled liquids. So you have some GIFs illustrating water freezing. So I'm going to play the animation down on the left. One of the unique properties about water is that when it becomes a solid, it becomes less dense. And that's because of the polarity of the water molecules. And that's something we'll talk about later. But the molecules spread out, which makes them less dense when water is a solid than when it is a liquid. So you can see here in the top right that when we have the solid, that the water molecule is still moving around, but it's not moving as freely as if they weren't attached to each other. I don't know what just happened there.
Get to Kohl's now for clear.
We will go back to where we came from. I don't know what happened. Okay, we're back. Question number 9 asks you to predict in which sample of water do water particles have more energy? In 5 grams of ice cubes at minus 10 degrees Celsius or 5 grams of liquid water at 20 degrees Celsius? So not only do they want you to answer the question, they also want you to explain why you answered that way. Make sure to use evidence or cite some facts to help support your answer. Number 10 wants you to label the boxes below each of the pictures of whether it is a solid or a liquid. Hopefully that's a pretty easy one for you guys to do. So we're going to look here real quick at a little video put out by the Canadian Natural Museum. There's no way I could draw this or explain to you the way that the video does. We probably won't watch all it, and I'll probably skip around. So when water is in the liquid state, the molecules can move around, slide past each other, and the little electric lightning bolt you see is due to the polarity of water. So there's this slight attraction that occurs between water molecules. So here the water molecules can freely slide around each other, and they're held close together by those little sparks. In the solid state, the molecules arrange themselves in a lattice or in a very organized way, and they actually spread out due to that property of water that we'll talk about later. But that makes water solid less dense than water liquid. And then when water's a gas, the molecules are moving so fast that they're not close enough to actually have that little spark between them to cause them to be closer and act as a water or as a solid.